Hey guys, okay, time to get back to solving systems. So last week we were solving systems and the last method we talked about was elimination, but we haven't finished it yet. So now we need to finish talking about systems with elimination. So let's just do like a little review first. So if we're going to be solving systems with elimination, remember our whole goal is we want to eliminate one of the variables. And to do that, the coefficients of one of the variables, so remember coefficients is that number that's in front of the variable, needs to be the same number but opposite signs, because that's how we can eliminate one of the variables, okay? Because if we have the same number but opposite signs, when we add them together, they're going to equal 0. We also need both equations in the same form, and they can be in standard form or self-intercept form, but they need to be in the same form. So this example was the first example that we did. So I was able to add these two together, and because my y had the coefficient of 5 and then this one had -5, those canceled out. And I was able to solve for x, and I got x. I took that number and substituted it back into one of the equations, and then I got my solution, which is my intersection point. Okay, my second example was this one right here. And with this one, we had to do a little bit more work because we didn't have the case where I had the same coefficient but opposite signs. Instead, they were the same exact coefficient. If I go ahead and add like -2 and -2, that'd give me -4, and I wouldn't have my variable cancel. So what we did is we manipulated one of the equations. So what we did is we multiplied this bottom one by -1, and when we multiplied it by -1, we got a +2 for my x, and so I was able to cancel out my x's now. And then I did the same thing. So now we're going to keep going with elimination, and we are going to look at this problem right here. So with this problem, as you can see, my coefficients for either my x or my y, okay, when I add, they're not going to eliminate because I do have two different coefficients. I've got 2 and 3, so those wouldn't cancel out. Those would equal 5 if I add them together. And then I've got 2, and remember, this is a -1, okay? If I add those together, I would get 1, and I still wouldn't have it cancel out. So we've got to think about, okay, how can I eliminate one of these variables? Well, think about it. Can I do kind of like what I did on that last example? You know, last example we multiplied by -1. Can I multiply by a number to get rid of one of the variables? And so I'm going to look right here at the y, at this bottom one down right here. This is a -1. If I wanted to eliminate right here, I want both of these y's to be the same number but opposite signs. Well, they're already opposite signs. I could turn this 1 into 2 if I multiply this whole equation by 2. So that's what I'm going to do. So, you know, sometimes you're going to have to multiply one of your equations by a number in order for it to eliminate. Look for that easy multiplication that can happen. Look for numbers that all you have to do is just multiply by something, and there you go. It's gone. It can work. Okay, so the top equation is going to stay the same. The bottom equation I'm going to multiply by 2. So I got 2 times 3x is 6x. 2 times -1y is -2y, and then 2 times 5 is 10. Now look, I've got 2 and -2. Those should cancel. So I'm going to add my equations together. So I get 8x. Those cancel out. And then I get 6 plus 10 is 16. And remember, I know I've eliminated correctly when I do have just one variable left over. Okay, so now I'm going to solve. So I'm going to divide by 8. Okay, 16 divided by 8 is 2. So I've got x is equal to 2. Okay, so I've got my x, but remember, a solution to a system is an intersection point. So that means we need an x and a y. So I have my x, so now let's get my y. So I'm going to take my x, I'm going to substitute it into either equation I want to. Maybe I'll put it into the top one because it really does not matter. So I'm just going to rewrite it here. But again, instead of x, I'm going to use 2, the number I just found. Okay, 2 times 2 is 4. I'm going to subtract 4. So I get 2y is equal to 2. Divide by 2, and I get y is equal to 1. So the solution to this, put it together. Remember, it's a point, so it should go x and y is 2, 1. I could easily check that just by taking this point 2, 1 and substituting it back into my equations up here and making sure that they are both true. Okay, so now let's look at my next example and let's see if we can figure this one out. So with this one, again, just adding them together is not going to work because they are not going to cancel out. They're not the same numbers, but opposite signs. Multiplying by -1 isn't going to work out because if you're going to multiply by -1, that means that you have the same numbers. They're just not opposite signs. So I'm going to look at this, and you know, there's not any easy way, like I could turn 3 into 4. With multiplication. There's not any easy way that I could turn 2 into 3 with multiplication. So when you have cases like this where, you know, you can't just multiply and change something very easily, what we're going to have to do is we're going to end up having to multiply both equations. Okay? So maybe when you have to multiply both equations, really just pick one of your variables that you want to work with. So maybe I'll eliminate, let's eliminate x this time. So I've got 4 and 3. Think about your multiples of 4 and 3. What's a common multiple between 4 and 3? 12. So I've got to ask myself, what can I multiply 3 by to get 12? Well, I multiply it by 4. What can I multiply 4 by to get 12? Well, 3. And remember, we need them to be the same number, so when I multiply them, they will be 12, but I also need them to be opposite signs to cancel, so maybe I'll multiply this one by -3. Okay, so I'm going to go ahead and multiply this one by 4. And then I'm going to multiply this one by -3. And then I'm just going to go ahead and add. So my x's will cancel. These two right here, 8 minus 9 will be -1y. 4 plus 6 is 10. Divide by -1 and I get -10. So there's my y, I need my x. So I'm going to substitute the y back into one of these equations. Maybe I'll substitute it into the first one. So I want to substitute it in for y. So 2 times -10 is -20. Add 20. Need 21, divide by 3, and I will get 7. Okay, so now I've got one last example that we're going to do. I suggest that you pause this video, try it on your own, see if you can get it, and a hint, you will get fractions. Okay, so this one again, I want to try to use elimination. I can't just add them together to eliminate, so I'm going to look to see what I can do here. And I can notice right here, this is a 1x. If I multiply this by -7, I can get rid of the x. I could also multiply right here by 2, and I could get rid of the y, because then I'd have -4 and +4. So you could really do it either way you want. I think I'm going to multiply by -7 right here. So that means the first one stays the same. Down here, when I multiply everything by -7, I'm going to get this. Okay, so now I've got to add these together. So 7x plus -7x is 0. 4y plus 14y is 18y. And then 2 plus -21 is -19. Divide by divide by 18, and you get y is equal to -19 over 18. Okay, I've got my y, so I'm going to substitute in to get my x. I think I'll substitute into the bottom one this time. We keep substituting in the top, so let's do the bottom one this time. Okay. So I'm going to substitute into y. Okay. -2 times -19 over 18 is going to give me positive 19 over 9. So now I would subtract 19 over 9, and I'm going to get x is equal to 8 over 9. Put it together. 8/9, -19 over 18. And there we go. I've got my solution. Oh, and I just realized we didn't write out our solution as a point here. We always want to write it out. Okay, so there you go. That is solving systems with elimination. I hope this has helped you, and good luck practicing solving systems with elimination.